All right, welcome to lesson 2.1.4, comparing linear functions in different forms. For the following scenarios, complete the following. Determine and then compare the rate of change for each function in terms of the quantities. On the track team, two long jumpers, Greg and Summer, are steadily improving their times for the 400-yard dash during the course of the season. Their times in seconds as a function of weeks are shown below. So let's take a look first at Greg's time. We're going to have to calculate his rate of change, which means we have to take a look to see how much are we increasing or decreasing every single time over here on this left side. So let's take a look. From 60 to 59, we are going down by 1. From 59 to 58, we're going down by 1, down by 1, down by 1, and down by 1. All right, so that's very consistent. That's a good thing because that means we have a very linear graph over here. Let's double check on the left side to make sure we are going up by 1, up by 1, from 2 to 3, that's up by 1, great. We are going up by 1 every single time. So it looks good. When we are calculating the rate of change, we're going to take this number and divide it by this number. So let's do that. -1 divided by +1. Once again, the -1 is the purple number on top, the +1 is the blue number on the bottom. Simplify this, and his rate of change is -1. But we need to put this in terms of the quantities compared. So -1 second per week. So Greg's time was improving by 1 second per week. His time was going down by 1 second per week. Okay, and let's take a look at Summer's times now. So for Summer's times, we are given 2 points on a graph. So I'm going to do this in green because why not? We have a formula when we are given 2 points to calculate our rate of change. So the rate of change is calculating the slope, which means we want to do y2 minus y1 over x2 minus x1. So it's the rise over the run. I'm going to zoom in over here because the numbers are a little bit tiny. So over here we have 0, 70. This can be our x1, y1. And we have 464. This is our x2, y2. Plugging it into our formula, we have our y2 minus our y1 over the x2 minus the x1. Okay, and then we are simplifying this some more. We get 64 minus 70, that's a -6, over 4 minus 0, that's a 4. Simplify this fraction by dividing both the top and bottom by 2, their greatest common factor. We get -3 over 2. So Summer's rate of change is -3 over 2. And what does this -3 over 2 mean? It means -3 over 2 seconds per week. Okay, so Summer's time is going down by 3/2 seconds per week. So when we are comparing these two, we must make a statement about it. So whose rate of change is decreasing faster? So -1 is a more negative number than -3/2 because well, actually, just kidding. Let me rephrase that. Let me restate that. -3/2, if you type it in the calculator, this is -1.5. Because I know you guys don't like fractions sometimes, and sometimes it's easier to see it as a decimal so that we can compare it better. So Summer's time is going down by 1.5. That's a good thing when you're talking about track, because in track you want a shorter time. So you want a smaller time. So if Summer's time is going down by 1.5 seconds per week, you can say that she is improving faster than Greg. Summer's rate of change is decreasing faster than Greg's rate of change. All right, so Summer's times are decreasing faster than Greg's times. Any questions for this one? Please call me over if you do. I forgot that this is a recording. I don't know why I just asked it into the recording, but if you have a question, please let me know. Let's go on to the next one. A sporting supply place sells balls for many different sports. The functions below show the number of balls sold over the course of time. So now we are comparing a t-table and an equation. So for the equation, it's very straightforward. You just have to look at the m value. What is next to x? So remember, we have y equals mx plus b. The rate of change is the m, so the thing that's in front of the x multiplied to the x. So in this case, our rate of change is 5. Okay? Rate of change 5. And it's 5 what? Well, the functions below show the number of balls sold over the course of time. And then you can also see it's footballs per hour. So you can write 5 footballs per hour. Oh, sorry, this is not footballs, these are volleyballs. Oh, that's big. 5 volleyballs per hour. Because this one's for volleyballs. My bad. So for this volleyball situation, we have a rate of change of 5 volleyballs sold per hour. Let's take a look at our football situation. And so for our football situation, what we want to do is what we did in the first problem. Take a look at how many it's increasing by. So from 15 to 25, you're increasing by 10. 25 to 35, you're increasing by 10. We're increasing by 10, by 10, by 10. That's all good. Let's double check on the left side. We're increasing by 1, increasing by 1, increasing by 1, by 1, by 1. Okay, so you're going to take the left side numbers, or no, sorry, the right side numbers, and divide it by the left side numbers. So we have 10 divided by 1, which gives us 10. So our rate of change for the footballs is 10. 10 footballs. Oops, that's not how you spell per hour. So then when we compare it, we are selling 5 volleyballs per hour and we are selling 10 footballs per hour. So you can make the statement that we are selling more footballs per hour than volleyballs per hour. Because the rate of change for footballs is 10, which is more than the rate of change for volleyballs, which is 5. So this is how you would compare the rates of change given a situation. So if you have any questions when you are doing the skills practice, please let me know and I'll come over to help.